All right, welcome to 4.1 again. We kind of sort of talked about 4.1 already. We talked about basically when x is this, f of x equals, and you plug in the x. There's some of the other stuff. Some of it's in 4.1, some of it's kind of the stuff from our old book, but I wanted to go over all of it. In behavior and intervals of increase, decrease are kind of the big things we're going to really focus on. So let me hide this real quick. So we start with if a polynomial is even or odd. Now, I have some generic ones here. Just note that x to the fourth does not always look like this. This could potentially be x to some higher exponent with just not as many wiggles. Like this could technically be x to the eighth. You just got to be. It was just a general like look. If they're if the two ends, because that's really what we're kind of focused on, if the two ends are going the same direction, both up or both down, our degree, which is our highest exponent, our degree is going to be even. So this would be like x to the fourth plus 3x squared plus 2x minus 4, or whatever it is. Of course, it wouldn't be minus 4. Intercept there, but you get the idea. Like, this is the highest exponent I'm going to see in that particular thing. If it's odd, I know it's odd because one of my ends is going up, one of my ends is going down. One of my ends is going up, one's going down. One's going up, one's going down. Now, they may go different directions or whatever. We'll talk about that more in a moment. But basically all this writing to say, look, we can then come here and say because this is going the same direction, both of them going up, I know this is even. And because this one's going up and this one's going down, I know it's an odd. Now, this one looks like it's x squared. This one looks like it's x to the third. But again, we can't tell for sure. Now, this slide talked about real zeros. Anywhere where it touches or crosses the x-axis. This is kind of the stuff we've been trying to solve this whole time, where we have two real zeros or two real solutions when we did quadratic stuff. This one only crosses once. It does have another change in direction, but this is not considered a solution, not considered a zero. Same thing here. These are great change of directions, not considered a zero. This one actually doesn't touch at all, so we don't have any zeros. Here's where it gets a little weird. And go and pause and write all this down, and I'm going to kind of start fresh and go from there. So here's what's happening. Start with the x-axis. We go this way, x is going to the right. But we don't say x is going to the right. X will eventually hit infinity. And in this case, it's positive infinity. If we go this way, x is actually heading towards negative infinity. So we don't say x is going right, x is going left. We use infinity or negative infinity to say right or left. Well, then we have up and down. Well, that's y is going towards infinity, up. Y is going towards negative infinity, down. Problem is, they don't like to use y. Instead, they'll call it f of x. So f of x is going towards infinity, positive infinity, or negative infinity. So what we're worried about is what's happening on the ends of these graphs. Well, we only have four options. It's either going to go up and to the right, down and to the right, down to the left, up to the left. And they could be curved, they could be straight. We just know that once they put the arrow on the end of that graph, we know which direction it's going. Now, let's start with this one up here. We know that we are going to the right and we are going up. So basically, we're going to take going to the right and going up and put it in this particular form. F of x is going up as x goes right. We don't talk about it that way. We say positive infinity and positive infinity. This next one, f of x is going down as x goes to the right. We don't talk about it that way. We say f of x approaches negative infinity as x approaches positive infinity. Now those are the same because they are both going to the right. All of our functions are only going to use one of these. We cannot have a function where both of them go to the right. So you just got to figure out, as we go to the right, are we going up or down? And then you choose one of these to talk about. Now over here on the left, it's the exact opposite. Y is going up as x goes left, but we don't say that. We say f of x is approaching positive infinity as x approaches negative infinity. And down here at the bottom, negative, negative. And again, those are the same because they are both going left. We're only going to need one of them. There's no way we're going to need both of the ones on the left or both of the ones on the right. We get one on the left to choose from, one on the right to choose from, based on whatever they give us. So perhaps they give us this. Well, this one's going up and to the left, so it's going to go towards positive. F of x is going to go towards positive infinity as x goes towards negative. This one's going down to the right, so I'll use this one. If it was something different, perhaps something like that. We would use this one because this one's going down as we go left. This one's going down as we go right, so we use this one. And I will say, let me go backwards just a little bit. Let's say we have something like this. This one's pretty easy. Is it going to take everything? Yeah, fantastic. This one's obviously going to use this one and this one. But what if it's sitting over here? Well, we know this one's going up and to the left, and this one's going kind of straight up, sort of. But no, this one will eventually cross over here and become this. This is still going to the right. It's just going to take a while to get there. Same thing goes over here, or like way down here. Like this is still going up and to the left. This is still going to be this one. It's still going up and to the right. Just because they stopped the graph right here doesn't mean that that line doesn't keep going up and to the right like this one. So you just got to be careful on some of those that you're just looking at where it stops. So here were the couple examples, and I actually said we're going to go backwards. C was find the real zeros, 1, 2, 3, 4, and 1. That was easy. B was if it's even or odd. Well, it's even because they both go the same direction. It's odd because one goes up and one goes down. Then describe end behavior. I said, well, what's happening here? And they said, oh, it's going up and to the left. I said, okay, well, when we go back here, up and to the left was this. So tell me this. F of x approaches positive infinity as x approaches negative infinity, which is what we wrote. And I said, well, what's happening here? Well, that's the positive positive. So f of x approaches positive as x approaches positive. And literally, once we found out like where it was going, we really just pulled from the other thing. And what we noticed was like these signs, if you remember kind of your coordinate system, these signs, and I can take that off, I'm sorry. These signs match up. X is positive, Y is positive. X is positive, Y is negative, but we don't say Y, we say f of x. Negative, negative, and negative, positive. Just make sure things aren't backwards, because if you say this is negative and this is positive, well, you're actually talking about this one down here. And so you just got to be careful. Last thing, we talked about intervals of increase and decrease. And we started with this blank right here. And I said, look, we're going down, we're going up, we're going down, we're going up. And we have to start somewhere. We have to talk about only an x, because talking about increase, decrease already talks about y. Increase means y goes up, decrease means y goes down. So we're really only talking about in between this x value and this x value, we are doing this. So we got to start somewhere. Over here, we keep going up and up and up, and they were like, oh yeah, that's up and to the left. So that's blah, blah, blah. And I was like, now remember, I don't care about the f of x. What's happening with x? They said, oh, well, that side, x is going towards negative infinity. So perfect. Negative infinity, it keeps going up, and then we're following this line, and we get to here. Well, what's happening here? Well, that's decreasing until we get here. Then from here to here, we're increasing. From here to here, we're decreasing again. From here to here, we're increasing, and this is going to go forever to positive infinity. So we would come down here and say, look, we are decreasing from negative infinity to negative 4. Negative 1, 2, 3, 4. Once we hit negative 4, we are no longer decreasing. We are increasing. So that's where the increasing from negative 4 to 0. From x is negative 4 to x is 0, we are increasing. from 0 to -5, or sorry, from 0 to 5, we are decreasing again. And from 5 to positive infinity, we are increasing again. And literally all you have to do is find where these changes happen and kind of make note of where they are. And just know that you have negative infinity and positive infinity on this side. And you just tell me from here to this first marker, what's happening. From this marker to this marker, what's happening. From here to here, what's happening. From here on, what's happening. It's either increase or decrease. Here's the homework for it. It wasn't too terribly bad. There's other videos on in behavior. There's other videos on interval, increase, decrease. If you want to watch those, like if this one didn't quite totally make sense, maybe come ask me some questions or whatever. Maybe find some other videos. I'm not really sure what else is out there, to be honest, but I'm sure someone's got. But hopefully this helps.